Okay, the solutions for the first worksheet, the area of a circle. So here we go, A1. A circle has radius 23 centimeters, calculate the area. Okay, so you know the area is equal to pi times radius squared. Okay, and you've been given the radius is 23 centimeters, so I can rub that out and put 23. Calculate the area of the circle. So I can just type that straight into the calculator and do move it out of the way. Oh no, it doesn't matter. Anyway, we've got shift pi times 23 squared. So the calculator is going to square this first of all and then times it by pi, and we get that. That is 100% accurate. And if the question says leave it in terms of pi, then that's it. If it asks you to round it, well, you have to SD it, and that is not accurate because pi is an irrational number, means that this goes on forever and there's no recurring pattern to it. So even the calculators had to round it up here, okay, because it goes on forever. So it's a lot more accurate to leave it like that. So 529 pi, and it is an area, so it is millimeters, sorry, it is millimeters squared, and that's the answer. Now I will accept that you might have rounded it, so SD and any correct rounding I'll give you. You know, it will, in the real exam it will tell you what it wants, lived in terms of pi, or round it to 1 dp, 2 sig fig, 3 sig fig. Okay, but it didn't specify what it wants, so I'm going to round it to 1 dp, let's say. So we've got 1661.9 millimeters squared. Okay, next question. Right, a circle has a diameter of 21 centimeters. Calculate the area. Well, again, area equals pi times radius squared. Now you've been given the diameter here. The diameter is 21 centimeters. The radius is what we need. The radius is a half the diameter. Diameter of a circle goes from edge through center to edge. That's the diameter. Radius goes from center just to edge. So it's half. Half of that is going to be 10.5 centimeters. So it is that has to be replacing that there. So 10.5 squared and then times by pi. So we've got shift pi times by 10.5, and don't forget to square it, and we get that answer there, which is 100% accurate. I'll keep on saying that. It is 441 over 4 lots of pi centimeters. Or did that again? Yeah, it is centimeters squared. Okay, and again, you might choose to round it, so it's less accurate, but you might have done that anyway. 346.4. 346.4 centimeters squared. Okay, so there we go. Number 3, a quadrant. Now a quadrant is a full circle. Sorry, it's part of a full circle, but I just draw the circle out. So there is a circle. A quadrant is a quarter of that circle. So I'm trying to get back to my normal pen now. There's normal pen. There's the center. Let's say a quadrant is that much. Whoa, that's not very good, is it? I don't think I'm going to much better. There you go. Quadrant is a quarter of a circle, so that's 90 degrees there. So a quadrant is cut from a circle of radius 14.5. Calculate the area of the quadrant. So we've got to work out the area of this quadrant that you're cutting away. Now we know that this dimension here is radius 14.5, so from edge to center is 14.5 centimeters. So again, the area of a full circle is pi times radius squared, but it's not a full circle, it is only quarter of a circle. You can see that because an angle here is 90 degrees of the full circle is 360, and that will cancel down to a quarter. That's why it's called a quadrant. So it is just a quarter of times pi times radius squared. Well, the radius is 14.5. Okay, so just type that into the calculator. Fraction button, 1 over 4, come out and times it by shift and pi, times it by 14.5, and square it. So the calculator is going to square this first and times it all out and give us the answer in terms of pi. And there it is. So again, that's 100% accurate. 841 over 16 lots of pi. It's an area and it is in centimeters squared. Now again, you might have run it to 1dp or whatever, but I'll just do it to 1dp. So 165.1 centimeters squared. So that's 100% accurate, and that's just been rounded. Question 4. A circular's diameter of that is cut in half. Calculate the area of each of the semicircles. So again, we've got a full circle. Where is it? There it is, sorry. Full circle. And a semicircle is simply half the circle. Okay. And it says the diameter, so this entire length here is 67 millimeters. And it says calculate the area of each of the semicircles. So we've got to work out the area of just one of these. Okay, so again, you know that area for a full circle is pi times radius squared. We've got a half a circle, so that's 180 over 360, and you can see that angle there is 180 over 360, which is a full circle. You can see it boils down to half. That is why it is simply a half of a full circle, a semicircle. The R, well, the diameter is 67, so the radius is from center to edge. It's only half as big, so that is going to be a half of 67, which is 33.5. So it is 33.5 squared. Type that into the calculator, fraction button, 1 over 2 times by shift pi times by 33.5 squared, and it gives us that answer just there. And again, that's 100% accurate. 4489 over, and I think it said 9, no, it said 8 lots of pi, and the length is in millimeters, so the area will be in millimeters squared. Okay, and the rounded up version for that to 1dp, you could have, you could have chosen other roundings, but I'll just do it to 1dp, is 1762.8. 1762.8 millimeters squared. Okay, so there you go. Next question. We're on to the section B now. A 10p coin has a diameter of 24.5 millimeters. Work out the area of one face. So just one side, the area. Well, no need to draw that out. We know that area, it's a full circle, it's a full coin, is pi times radius squared. Now you've been given the diameter, so we've got to halve that. So radius is simply 24.5, and we're going to divide that by 2. Okay, and that will give us 12.25 millimeters. So I'm replacing that with 12.25 and then working it out. So calculator, it is shift pi times 12.25, and we've got to square it, which gives you that there. So it is 2401 over 16 lots of pi, and it is in millimeters squared because the length was in millimeters, so the area will be millimeters squared. And again, if you've rounded that, SD it, we're going to get 471.4. So 471.4 millimeter squared. Okay, and that's the answer for that one. B2. Right, a regulation dartboard has a diameter of 451. Work out the area of the dartboard, give you an answer in centimeters squared. Okay, so the diameter was given. So the area equals pi times radius squared. You've been given diameter, so the radius is equal to 451 divided by 2. So calculator, 451 divided by 2 gives us that, which is 225.5. 225.5 millimeters. and it is that I'm going to rub out there and put 225.5 and square the radius. That's the radius squared. Work that out, and we've got shift pi times by 225.5 squared, and we've got that massive number 203,401 over 4 lots of pi. Oh, sorry, I just noticed something. This is in millimeters, and it says it wants the answer specifically in centimeters squared. You can get millimeters squared, and I've shown you before how we convert that back into centimeters squared. But it's a lot easier to convert this into centimeters. So before I go ahead, divide it by 10, because there's 10 millimeters make a centimeter. That's going to give you 22.55. Now I'm not going to round up, that is the number I'm going to be using, that is in centimeters. It is that number now that I'm going to be using just there, which is 22.55, and we've got to square it. Okay, so we've got shift pi times by 22.55 squared, and it gives you that, which is 203,401 over, I think it said 400 lots of pi, and it is centimeters squared. Let's just check that, 203,401, and then to round it, well, sorry, we'd have got 1597.5, 1597.5 centimeters squared. Okay, that's the answer. B3. The circle has circumference 21 centimeters, so its circumference is 21 centimeters. Work out the area. Well, circumference is equal to pi times diameter. So the circumference is 21 centimeters, so I can rub this out and put 21 centimeters. To undo this, to work out what the diameter is, to undo timesing by pi, I'm going to divide that by pi and divide that side of the equation by pi. So I end up with 21 divided by pi is equal to the diameter. Therefore, the diameter is equal to, and on the calculator, it is 21 divided by pi, and we end up with that nasty number, 6.68, and we never round up, so put 3 dots in. It is in centimeters, the circumference, so the diameter will also be in centimeters. We're not rounding, we're going to store that on the calculator by pressing Shift, Stow, and choose a letter, A. So I've stored that number. Now, I'm now going to work out the area. Well, the area of the circle is pi times radius squared. Well, the radius is half of this, so radius is equal to, get my previous answer and divide it by 2. Okay, so you could say divide that by 2, and we get, and again we're not going to round it up, it is 3.34 dot 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 3.34 dot 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 centimeters, and it is the radius that I'm going to shove there. So it is 3.34 dot 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 squared. So I have got, I don't need to store it this time because that's my last answer. It is simply, you know, sometimes you're going to use it later on, it's wise to save it, but here we don't need to. So it is Shift pi times by the radius, which was my previous answer, squared. Okay, and that's the answer we get. It has rounded it up, so I've got to truncate it further. It is 35.1 centimeters squared, and that's been rounded to 1 dp. Okay, next question, B4. The circle has an area of that. Work out the length of the radius of the circle. Well, we know the area is equal to pi times radius squared. Now we've been given the area, so I can rub that out. We know the area is 32. And to undo this, the first thing I'm going to undo is divide by pi and divide by pi. So you end up with 32 divided by pi, which is equal to r squared. And to get just the radius, to undo squaring, you're going to square root both sides. Square root that side, square root that side. So we know therefore the radius is simply the square root of 32 over pi. That's what the radius gives you. Okay, so radius is equal to, on a calculator, it is shift root, sorry, I don't need to shift it, sorry, it is just simply root of fraction, and it is 32 over pi, which is just there. Press equals, and we get 3.19. That will do me 3.19, and it's a length. If the area is in centimeters, the radius will be, sorry, if the area is in centimeters squared, the radius will be in centimeters, and that is done to 2 dp. Okay, next question, C1. A round dinner table has an area of that. Work out the length of the circumference of the dinner table. So we know that the area is equal to pi times radius squared. So I'm told the area is 2.84, and that is equal to pi times the radius squared. We need to work out the radius. So to undo this, again, we're going to divide both sides by pi. So we end up with 2.84 divided by pi, and that is equal to r squared. To undo squaring, we square root both sides, and we end up with the square root of 2.84 divided by pi, and that is what the radius is. So work it out on the calculator. It is the square root of 2.84 over shift pi, press equals, and we get r is equal to 0.9507, and we never round halfway up for 3 dots. We got to work out the circumference, and we know that circumference uses diameter. Circumference is pi times diameter. So I'm going to need to know the diameter. So we're going to times that by 2 to give us the diameter, which is what I want. So calculator, there's my previous answer, times by 2 gives you 1.90, and to tell the examiner it goes on, and it's meters, so this is going to be meter squared, it's meter squared there, so this is going to be meters the diameter. It is that I'm going to shove there. So it is 1.90 dot dot dot. Again, we use the unrounded version. So the circumference of the dinner table is that times pi, so times by pi, which is equal to that there, 5.97 rounded up, 5.97, and it's a length. If the area is in meters squared, it will be meters, and that is to 2 dp. Okay, C2. A semicircle has an area of that. Work out the perimeter of the semicircle. So again, we've got a semicircle. If I just get my shapes. Okay, circle. There it is. Tools, back to normal pen. So we've got a semicircle, which we're looking at here. So I've got the area has been given. This area just here. Well, we know that area is equal to, and that is 180 degrees over 360. It is a half of a full circle. A half times by pi times by radius squared. Now you can rewrite this as by saying a half times that is the same as saying pi times r squared divided by 2. So I'm going to use that. It's the same thing. Now you're told that the area is 20 centimeters squared, so I can rub that out and put 20. Now we're going to rearrange this formula, this equation if you will, to work out what r is. But we need to get rid of these things. Well, the first thing we need to get rid of is the divide by 2. So we're going to times both sides by 2 to give us 40 is equal to pi times radius squared. The next thing I'm going to do is get rid of the times by pi by dividing by pi and dividing by pi, and that gives me 40 divided by pi is equal to radius squared. And to get rid of squaring, you square root both sides. So the square root of 40 divided by pi is equal to the radius. So we've now got the radius. It says work out the perimeter. So we're going to use the circumference, but you only want half of the circumference. And then perimeter means you've got to add on this final line. So we're going to add that to that. So we're going to need the diameter. Well, first of all, let's work out what that is. The square root of 40 divided by pi, so shift pi, and that gives us that. So r is equal to 3.56 dot dot dot. The area is in centimeters squared, so this will be centimeters. Let's just check that. Yep. And don't forget, we're going to double it because we want the diameter. So therefore, the diameter is equal to, times that by 2, and we end up with 7.13. 7.13. Now I'm not rounding, so you can see it's a 3, so just put 3 dots, and that will be in centimeters. Okay, so coming back up to here, I can now work out the perimeter. So the first thing I'm going to work out is this arc length here. Now this arc, where's my highlighter? There. This arc length from here to here is what we're working out, this curve from there to there. And then, because it's perimeter we want, we're going to add on this line just here afterwards. Okay, the diameter. So circumference, we're going to use the formula circumference equals pi times diameter. Well, arc is only part of the circumference. How much of the circumference? Well, we want half of the circumference. So it is pi times diameter divided by 2. In other words, a half of pi times diameter. So we end up with pi times diameter. Well, the diameter is down here is 7.13. 7.13 dot dot dot. We use the original answer divided by 2. So we get that previous answer. So we got fraction, shift pi times by previous answer, all divided by 2 gives us, and we get 11.2 dot dot dot, and it is in centimeters. That length there is that. We're not rounding. And therefore we can finish it off by saying perimeter is simply 11.2 dot 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 unrounded plus this length just here to close the shape up. So this length here is the diameter. The diameter is 7.13. 7.13 dot dot dot. And you can see I should have saved this. So we'll go back and do it again. Okay, so I can save it. Here we go. I saw what I mean. It is the square root of fraction 40 divided by pi, which is shift pi, and then we go times that by 2. Now we're going to be using that number again. I forgot to store it. So here we go. Shift stow. I'm choosing A. So what I've got here is get my answer back there, which is pi, so fraction, shift pi multiplied by my previous answer divided by 2. Okay, which is equal to what I've just said there, but I need to plus my alpha A, what I've just stored it, that's the diameter, and my final answer round up is 18.3, so equals 18.3, and that is in centimeters, and it is done to 1 dp. Okay, it's only there that I've rounded it up. Okay, C3 over the page. Nathan eats a whole 12-inch pizza. Joshua eats half of a 10-inch pizza and a half of a 14-inch pizza. Who eats the most? So let's look at Nathan. So Nathan. Okay, so we're looking at the area. So we've got area, that's because that's how much is eaten. Area is equal to pi times radius squared. And when it says a 12-inch pizza, what that is a pizza, and they say, oh, 12 inches going across here. Okay, so that's the diameter. We want the radius, so it's got to be half of that. So that's going to be 6. Now these will be measured in not centimeters, it will be measured in inches. So the area will be inches squared. So working that out in the calculator will give you 6 times 6 is 36. 36 times pi is written as 36 pi. I could do it on the calculator, but I'm not going to. And that is square inches, or inches squared. Okay, that's what we get, what Nathan eats. Now on the other hand, we can look at Josh. Okay, and he eats a half of a 10-inch. So area is equal to, and again, if that's 10-inch, half of that will be the radius, which is 5. So it is pi times radius squared, so that is 5 squared, and he only eats half of it, so half of it. So calculator, no, I don't need a calculator. 25 times pi is 25 divided by 2 lots of pi, and that is again inches squared. But he also eats and half of a 14-inch pizza. So again, that is area equals pi times, and again, if that was 14-inch pizza, it'll be half is the radius, so it's 7 squared, and he only eats half of that, so it's divided by 2. So that'll be 49 over 2 pi inches squared. So I've now got to simply add that to that. Okay, so in total he eats, total is equal to 25 pi over 2 added to 49 over 2 pi. You do it on the calculator, but I'm going to add it up, gives you 60, 74. 74 over 2, well 74 over 2 cancels down to 37 pi inches squared. That's how much he eats. So therefore you can see he eats one more square inch more than he does. So therefore, I'll finish it off by going across here. Therefore, Josh, show clearly working who eats most pizza. Josh eats most pizza. One inch squared more. Okay, last question we've got. It says Penny is varnishing the floor of a circular room of diameter 5 meters. 1 tin of varnish will cover an area of that. Work out the number of tins of varnish Penny needs to buy to varnish the whole floor of the room. So we're going to work out the area in meters. So we're checking these, yeah, length and diameter, that's fine. So it's a circular room, so area is equal to pi times radius squared. And you've been given the diameter of that, so half of that is going to be 2.5. So 2.5 squared is 6.25, I think. So 2.5 squared, which is 6.25. Okay, I'll leave it as 25 over 4 pi meters squared. That's how big the room is. Now, 1 tin only covers 8 meters squared, so we're going to need to work out how many times that will go into there. So therefore, 25 over 4 pi divided by 8, and that gives us. So there's my times that by pi to get pi into it. Okay, so there's my answer previously, and see how many times 8 will go into it. 2.45, so 2.45 ... times. So well, I will need 2.45 tins. You can't buy 2.45 tins, so therefore Penny will need 3 tins. Okay, and that's the last question. Okay, some good questions there. If you understand every bit of that, then you won't have much trouble getting a good grade in the foundation paper. You should be well on for a level 5 if you can do all of that. So there's some good questions there. Okay, I hope that helps.